Hello, Andrew.
Hello, I've just realized that once again I'm in the wrong call. I've got a clashing call, which is why I haven't been here. I hope you're well and enjoy this call. It's
Thank you.
more pleasant.
I miss so much the strobing light effect when Scarbeck joins a meeting.
Well, let's get it going. Which one was it? Is it this one? Yeah.
But is it an effect? How are you doing it? It's another
So,
camera?
Yeah, my laptop has an infrared camera along with its normal camera. I think Windows uses it to help identify you and helping log in, but I don't use Windows, so it's completely useless. So like if I lift the lid, you can see the trackpad underneath the camera.
Yeah. Okay, so this is pointing, it is in the closed lid of your laptop pointing to the...
Yeah, it's right next to the normal laptop camera.
Yeah, okay, understood.
So yeah, there's that. Welcome to the Kubernetes demo, everyone.
Rock solid start once again.
We talk about infrared cameras.
How's everyone doing?
I'm doing fine.
Yeah, it's terribly hot, but I'm fine.
It's still hot. Sympathies.
Cold and rainy here, but I'm also doing fine.
Okay, good. Ruben, you doing fine?
Yeah.
Good. So exciting demo today. Scarbeck, over to you.
Yeah, so it took us 3 attempts. So far, we haven't rolled back yet, but we are taking traffic inside of the canary stage on Kubernetes. So I'm just going to show a few not really anything exciting dashboards. Here we can see that, our AppDex is wiggly, but like it's always been wiggly. If I go back to 7 days, which would take a while to load, it always looks a little, okay, the granularity changes. So maybe not 7 days, maybe 2 days. Okay, still can't see it very well, but we are taking traffic inside of Kubernetes, which is pretty exciting. One of the things that we fixed, let me go back to that 2-day view. When we first rolled this out, we were seeing high memory saturation. We were using the default values that we use for all of our web services, which is set to 6 gigabytes for our memory limit, which is how we derive how close we are to our saturation. Thank you to Henry for helping me with the MR to review that. So we are now seeing saturation just shy over 80%. I think after we complete the migration into the main stage, we'll probably revisit the tunings for the service overall, which will definitely change the saturation.
Maybe we should keep in mind that this is the maximum, right? So there might be one pod always going very high, but the majority is, I guess, mostly below it, right?
Correct.
So it's not that all of them are using that much memory, just one might be very high.
Yeah, I feel like we should have like a median or maybe the average instead of the max, but whatever. As you can see, we did fix our metrics. This is when we first implemented everything and the metrics just kind of dropped down to 0. I wasn't watching this chart. I was paying attention to only these things up here. I did see the memory saturation, but like when I was doing the migration, I'm like, we could toy with that. I'll revisit it later. But yeah, so our metrics are now fixed. So we have the data necessary. Interesting point about metrics. Let me see if I could go back to our main stage, because we did make a mistake yesterday and I accidentally induced an outage because of that when I was attempting to fix the metrics. It might have been this period of time. When I was making a change to our metrics, there's one, yeah, it was this one. It looks just like it did. When I was making a modification to our metrics, we have a very similar query to our API, but what was missed was that it wasn't looking for workhorse specific to the web fleet. So during this time in which AppDex plummeted, what was happening was that we were gathering metrics for workhorse across all of our services inside of both Kubernetes and our virtual machines. So instead of only taking into account roughly 5,000, well, I guess nearly 10,000 requests, between 7,500 to 11,000 requests, we were taking into account like over 14,000 plus requests because it was workhorse across everything. Oops. I don't know why we don't see the RPS change here, but if we go to staging, I think this is where I'm like, oh yeah, I'm doing something wrong in our query. But I don't know why that same thing didn't show up in production when that change was rolled out. But that highlights an issue with the way that we deploy our rules for Prometheus, because I can't create something that targets only production and staging. So I can't test something in staging and push it out to production. But anyways, so that's our metrics. Log-wise, this is a chart that's showing how much traffic on Sage Canary of type web, avoiding our
Sorry,
health
Skarbek,
and web.
regarding
Yep.
testing thing. So do you refer how we can test the metrics? So the dashboard or the metric itself?
The metric itself, like these are
Okay.
reporting rules that
Okay,
change.
recorded.
That's
Okay,
why
fine.
that's why after we adjust the metric, like we're stuck with this dip. So
Yeah,
like
yeah,
if
understood.
this impacts our SLIs that get reported above us, well, I accidentally just made it look bad, which is not great. So so this is a chart showing all of our Canary traffic for type web, avoiding the health control in the web exporter, because those are always being hit. And we can see the majority of our traffic is Kubernetes. In fact, if we get rid of, if I re-enable this filter, we see some traffic going to our virtual machines, but if you go to what that traffic is, we just recently had a deploy. So all you see here is us starting and stopping the services on our virtual machines. So that's good. That's the only thing we see is non-client related traffic go to our virtual machines. So I'm happy about that. So what I look forward to is removing our main stage from taking traffic instead of our virtual machines. I want to see this to turn green. So that'll be exciting. Which goes nicely into our topic of discussion. We have one readiness review left over from the infrastructure side of things. I mistakenly assigned one of the reviews to someone who was on vacation. So I got 2 volunteers to help with that. One person's already completed the review, another person is doing that today. So if nothing comes out of that review, that's super exciting. I think our target would be early next week would be the next time that we shoot for performing the migration.
Yeah, that makes sense. I was chatting to Graham this morning. I think with the release coming up, it fits in well with timing anyway. So yeah, let's aim for next week.
The change request he's still working on. I'm trying to figure out a way that we can reduce the severity, not severity, but like the change level, I guess, because currently it's labeled as a C2, but we could do this as a C3. That way we're not being a blocker for auto deploys, and because it's going to be a multi-day thing. So we don't want it to be a very high C level change anyways. Yeah. We just need to tweak some of the steps to enable that to occur, which is not hard.
Cool. Yeah, that sounds good. That sounds good. Super. Do you know, so one thing that was a kind of, I guess, a question mark, maybe it's too early to tell, but one thing that was a question mark around removing Nginx was whether we would see performance impacts. Is Canary an environment where we can get an indication of whether we have impacted performance, or do we need to wait for the main stage for that?
We should be able to compare Canary before and after running on Kubernetes for that.
I had the same question because when I looked last time when we enabled Canary for the app decks, for instance, it looked like at least as good as before last week, maybe even better. But now if I look at it, it's not really a big difference. So I guess also we need to look into logs, right, Skarbek, for really figuring out if maybe some percentile of latencies got better or worse. And we should be able to filter this for Canary, I think, to see this.
Yeah, that's what I'm trying to figure is how we would find that information. Because realistically, only HA proxy is going to give us that information.
Yeah, then it's harder.
And we'd
I
have
just
to use
find,
BigQuery to figure that out.
I mean, we can certainly look at it on the main stage. Like I was just curious because I know as far as it stands, I think that was the only real question mark that was left from like the testing Graham had done was actually whether there's like there probably isn't, but there may be some small change. So we can look at that next week. That's fine. Awesome.
That's a good question. I'm not sure how to find that information because from a technical standpoint, you remove an object that measures things. We removed Nginx.
Yeah.
So because we don't have that to measure because it's gone, I don't know how to say, hey, yay, we improved or degraded performance. I guess we already have AppDex for Canary. So we haven't negatively impacted that as far as I could tell. But our true method of determining whether or not we did any sort of improvement, we would have to look at HA proxy and look at the response times from our backend.
Okay.
But that's in BigQuery, and
that's okay.
I'm not good at looking at that data.
That's all right. I'm not expecting it to be faster. The main big thing is stability, right? So we should see like fewer odd stuff happening, which is good. Cool. Well, we can monitor that next week. That sounds good. Did we put out a message to let all of reliability know that we've gone back into Canary?
I did not see a message from Graham. I don't know. I don't pay attention to the on-call handover issues, so I don't know if it was included in that.
I mentioned it in the EMEA reliability discussion today.
Okay.
Don't know if he put it into the chat very visibly, but at least there he mentioned it. And there's for some discussion, he also mentioned that no chef changes to web should be applied if possible, because we have it in Canary mostly now.
Cool. Okay, great. So yeah, let's just keep repeating that so that as many people as possible know where we're up to. Super exciting stuff.
I'll make sure I bring the same messaging up to the Americas D-Day meeting as well. Cool.
Awesome. Sounds good.
Okay, so I guess time is permitting. So I guess I'll do a quick review of an investigation. Didn't really prepare this because I thought we'd run out of time. So what's going on, Zoom? So this issue, we had an incident where the SSH service SOI was violated during a deployment. What this chart is showing is the amount of ready pods per cluster. So cluster B is in yellow, cluster C is in blue, and cluster D is in red. The incident was primarily during the time in which cluster B was performing its deploy. I don't know precisely what initially triggered this, but we could see during the deploy, we scaled up a few pods, but we immediately brought them down. We scaled up some new pods, and then we just kind of crashed. What we had was a lot of kill events occurring at that same time. So looking at the memory profile during the deploy, we were at our limit. So this is 1 gigabyte, and we were pretty much at our limit. So any pod that was at that limit was going to get killed. But what I also saw was some saturation at the node level. So this is the amount of memory free. And then later, Matt Smiley came in behind me and showed me a different chart somewhere in here. Not entirely contradicting what I was saying, but like we still had memory available, just not down to 0. So we had like 3.5 gig left on server nodes. So I'm kind of surprised that we had some kills in general. But like we did have quite a few. We had 149 events where things were being killed. And of course, I can't pull this chart up anymore because those logs will have been rotated out because time has passed. But it's a mixture of either specific client events being killed or the actual process that manages the pod itself. And when the process that manages the pod gets killed, that entire pod gets removed from rotation. So what likely happened, and this is the event of the kill events on different nodes, what likely happened is that we brought our capacity down to so little because we reached, what's the bigger version of this chart? We went from running 35 pods to just shy over 20. And like prior to the deploy, we're running at a nice constant 35 in cluster B. If we lose enough capacity, we're not going to be able to serve those client requests because we'll have saturated those pods in various ways. We've seen in a previous incident where when the API went down for a period of time, GitLab shell ran up its CPU usage off the charts. In this particular case, our memory usage went way too high. So I think GitLab shell is one of those workloads where we need to figure out a better way to tune it. Because during our normal usage of this workload, oh no, I closed my tab. During our normal usage of this workload, we're greatly over provisioned. We're only running between 2 and 3 pods on these nodes. And if you go somewhere, this is what I get for not preparing. Let's see, we've got nearly 6 gigs of RAM that we could allocate, but we're like sitting here at using less than 2. This blue line is how much we use. We're not using very much RAM at all. So like a lot of the resources on these nodes are just not being used at all. But during times in which we are suffering, we'll use all of it and the node itself will start to suffer. So I created a new issue. And this is something that we've briefly spoken about multiple times over the course of the last 2 years, is wanting to be able to scale on custom metrics, which we would need to then tie into Prometheus to pull a custom metric and figure out what that custom metric is going to look like, whether that's something that currently exists or maybe it's a metric that we create. But the ability here would be that instead of scaling on the CPU usage or the memory usage or a combination of both, we instead scale on, say, the number of clients that are connected to GitLab shell. I know from, sorry, let me go find another chart. Okay, so here's the number of clients that were connected to the average number of processes, which to an extent correlates to the number of connected clients to GitLab shell. We know that when we get to a high number, we start to saturate our pods. So in this particular case, it looks like we started to struggle when we shot from roughly under 20 to something, say, over 30, because we started to recover on the downward trend up here. And this is primarily because we also started to scale up. Our HBA started to take control and help us out here. So I think if we were able to scale based on this metric, we would have a better shot at determining what a better utilization would be for these pods overall. It's just a matter of time and effort to get us to that point.
Did we ever get anything, or did we ever ask the GitLab shell team about the architecture, because I feel like this changed at some point in the last like 6 months or so, and started causing us more of these, well, maybe not these sorts of problems, but it started to use up more memory and stuff. Did we ever ask them about that?
Not that specifically. I did ask them if we buffer anything inside of GitLab shell. And I didn't receive a solid answer, but it sounds like the answer is technically no, that they pass the information directly to Gitly as necessary and vice versa. But the one thing I did put a feature request in for was to see if we can't ask both Gitly and GitLab shell to see if we can't log the amount of data that is being transferred to and from the client. This is a common thing that we log for HTTP requests, but we don't do the same thing for this particular service.
But this thing interacts with Gitly with gRPC call, right?
Yeah.
So I remember a conversation that I had with Jakob when I was working on some improvement about cloning stuff. I think we were discussing about this now. I don't remember details, it was too long time ago. But basically what he told me is that the process, the gRPC architecture is well designed for short and small data transfer, but when you start moving chunks of data, it just becomes a memory hog, because basically it just allocates and buffer things, converts them into from the internal structure to the wire structure, then it serializes them and send them over the wire. And when you receive the same thing, right, just have to pick the packet, just convert it to the memory structure and things like that. So maybe it can be related to this, because it really depends on which kind of operation we are doing. But at least he told me that, I think we were discussing about cloning. Yeah, I think we were discussing about cloning. So there was some type of gRPC call or in cloning, they were just taking a lot of memory. And this depends on the size of the repository, obviously.
Yeah. And one of the things that Matt Smiley noted was that when the memory killer came into play, a lot of the times it was killing processes that weren't using a lot of memory, which is kind of problematic, because that means we are serving a lot of requests, but then there's not much the node can do to help keep itself stable and healthy. So it's likely that we were just bottling up a lot of connections on these pods. So they were suffering is really what it boils down to. So I know GitLab shell is in the process of reworking how GitLab shell operates entirely. So I don't want to delve too deeply into trying to figure out what we could do better for that service at the moment, because I feel like in the future, that's going to change significantly with them introducing a daemon versus the current method. Secondly, well, I had a second point. Okay, I lost my train of thought. Sorry.
We can still counter your first point, which is maybe we are focusing on something that is not affecting this. And now that we are in a major architecture refactoring, maybe it's a good time to think also about this, because maybe we just changed stuff and then the underlying problem is still there.
I just had a look at the memory usage of GitLab shell during that day. I think it was on the 12th, right?
Yeah.
And it looks like a very strange pattern, like over, I don't know, 2 or 3 hours, we had very low usage on this cluster B, I think I'm looking at. And also it's very spiky, right? It's going up and down and like doubling the amount of usage in between. So I think the pattern of usage of resources is very erratic in general for GitLab shell, right? So it's easy to fall into something like going over limits or something. So I think the only way to protect us is really to set limits so that we don't risk to, run out of memory on the nodes.
So precisely, I don't want to change what our current memory limit is, because that's protecting our nodes from, dying. I'd rather protect the node over a single pod, because otherwise we would bring down a large portion of our cluster if that were the case. So going back to one of the corrective actions I pulled out of this is that we adjusted the deployment strategy. So previously we were using the default Kubernetes provided defaults, which enables us to remove 25% of the capacity while adding 25% of the capacity during a deployment. If our pods were failing during a deployment, which was the case in this particular situation, we were removing 25% of the capacity, thereby allowing any new nodes and any existing nodes that still have yet to be rotated out during the deploy to suffer more. And I think because of that, we started hitting our memory limits, things were getting killed, and that was just a cascading failure until things got to a stabilization point. What that stabilization point, I think, was the deploy had eventually finished and the HPA then was able to kick more pods into place. So I modified our deployment strategy that we already use this for our web deployments, where instead of allowing 25% of our pods from being taken out of rotation, instead that value is now 0. So instead of scaling down or up at the same time, we only scale upwards before we start tearing down old pods. And those new pods have to be up, ready, taking traffic before any older pods get taken out of rotation. And in fact, if we look at our latest deploy, we see that we scaled up new pods and then we were doing a little wobbly effect during the deploy, and then we went back down to where we were. So we started at 45 prior to the deploy, we finished with 45 pods, and then our HPA is doing its job as load happens. So that's precisely what I would want to see. And thereby we're not unnecessarily cutting capacity just so that we could do a deploy. HPA is the horizontal pod autoscaler. Currently we utilize CPU as a metric to determine what we scale based on. In this particular case, when CPU usage scales up or goes up because of load, we'll add new pods, and vice versa. When CPU usage goes below a certain threshold, we'll remove pods. This is the one thing that we don't have with virtual machines. So we're not able to scale up our workload to handle client requests instead of having to wait for an infrastructure engineer to be like, hey, our CPU usage is too high, let's add 3 nodes. And they spend the next 2 days trying to figure out how to accomplish that task. Now it's just automatic.
Back to your point that you made, Alessio, what were you talking about, the GitLab shell architecture as opposed to our infra?
Yeah, I was talking about the GitLab shell architecture. So you said if you are rethinking it, maybe it's worth just to put also this question on their plate, so that when they are thinking about what to do, they may consider also this type of, because I just very briefly, just as an idea, right? So if as Henry pointed out, the memory behavior is erratic. So probably we need something which is more within the business logic that can really, let's say, made a guess or an estimation about the incoming request, how much memory will it take. And probably this is the type of project, the type of software where we need to have a tighter memory management within the process itself. So let's say something like this. We get a new client and we know that we have a memory limit because we're running in Kubernetes. So we need to bring this information down in the process. So we know that we have an upper limit of, let's say, 1 GB in this pod, right? So the process know how much request is serving and roughly the memory that is using. So if there is a gizerly call that can kind of estimate the amount of memory needed for the incoming request, it will make an informed decision about serving it or just putting it in a queue. Because you don't want, if this is serving more than one request at the same time, you don't want the pod to be killed. And maybe just for an incoming request, you're just raining other 5 or 10, 10 or 20. Because if I remember, we were talking about 10, 20 requests per pod. So that's the type of situation where I'm thinking.
Something to keep in mind is the way the GitLab shell currently works. Right now, when you make an SSH connection, GitLab shell spins up a brand new process for each new connection. That in itself has its own memory overhead, whereas the future architecture is GitLab shell becomes its own daemon. It's running the necessary TCP stack to accept an SSH connection, and it's not spinning up a new process, but instead it will be a single process that could then do exactly what Alessio
exactly.
stated is managing those connections as necessary, and it'll have its own memory capabilities because it's managing all of the connections instead of a single process that is disconnected from all of the others. So the architecture will be better. It's just a matter of what are the future impediments or future situations that we need to be aware of whenever we turn that on. I don't know what the timeline is. I know our Helm chart now supports switching over to the new shell daemon, but I don't know where that team is at with potentially rolling that out.
Can we find out? Like, because I think like that would be a great one for us to like plan stuff, but also know how much we should worry about this stuff for metrics and things. Like, fine if it's just a comment on this issue we have, like especially we can link them to this video and see if there's any kind of practical stuff.
I'll figure, I think, yeah, I'll do just that actually.
Super, thank you. Awesome. Does that give you what you need, Skarbek, for in terms of overviewing like this thing? Is there anything you need from our side today to help here?
For this issue, no. So at this point, I've kind of completed my investigation. I pulled in a few other persons who are curious about this. They've kind of completed what they wanted to see out of it. If anything, Jakob may have more questions, but I'm going to go ahead and proceed to close this issue at this point in time. I've already completed an initial corrective action that I think was the most beneficial, and I just showed the chart, so I think we're in a good state. So I want to continue spending time on getting our web service migrated over.
Mm-hmm. Awesome, cool, sounds good, great. Cool, and then goals we've kind of touched already: readiness review and change request. Is there anything else? And do we need to give anything, provide anything, or help with anything?
That I know of. I commented on the CR that Graham has started to hopefully make it a little easier on ourselves. And then I've got one person that's doing the review on the or performing a readiness review. So those are the two things I know of that's going to be holding us up. But I think we're getting near ready.
Super, great stuff.
So
Exciting.
hopefully we could, do the migration 4 times in production.
Nice. On the we can see it probably, I'm sure there on the MRs, but on the main web rollout, like what's the kind of rollout plan? Are we going cluster by cluster, or how are we gonna get this out to the main?
The current plan that Graham has put together looks like we start by introducing the new configuration, 1 cluster at a time. Here, I'll roll through this real quick since I've got have the issue up. So we've got a chef change, and all this does is add for 1 cluster the back end of the web endpoint to that back end, and we do that per cluster. So at this point, 1 set of HA proxy nodes will send 3% of their traffic to that cluster, and we'll get to that point at the end of, I guess, day 1. Wait an hour. Yeah, so wait 1 day. So day 1, we do just the initial chef change across our front end nodes. After that, we just play with the weights, and we'll just play with the weights until we reach 100% of the traffic being in Kubernetes. that's the initial plan. This is a little bit intrusive because it involves stopping Chef on our FE nodes, executing the merge request, and then running Chef. I guess you don't have to do it targeted because we're doing this one cluster at a time, but I think we can make this easier, and then we could reduce the change level from C2 to C3. That's what I'm going to try to encourage for Graham.
Super.
Well, I have via comment, but
Cool. Okay, great. Sounds good. Brilliant. Right.
Cool.
Is there anything else we need to go through?
I don't have anything else now.
No? Okay, awesome. Thanks so much for demoing Scarbeck, and yeah, exciting, great progress. Exciting to see see things on Canary, and looking forward to the next step.
Indeed.
Awesome. All right, everyone, have a good rest of your day. Speak to you soon.
Have a good one, everyone.